Hola, mi clase. So we're doing 7.2 today, but we're going to split it into two parts. And so it's because this is solving equations with rational numbers. And so I wanted to split it into one day with just fractions and then one day with decimals so that you were bombarded with both. So the main things to think about and know about today are the LCM, which is the least common multiple. It's the common multiple, the smallest common multiple of two or more numbers, and then the LCD, which is the least common denominator. Apparently it's a denominator. Denominator. There we go. It's the smallest number that can be used for all denominators of the fractions. So these come in handy when we're dealing with fractions, right? So there's two ways you can do this. You can change these to common denominators, right? So I can put this one over 1. But to do the common denominator, I need the least common multiple, right? So the least common multiple, if we remember, is like our multiplication chart. So stuff like if I listed all the ones, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, right? These are all the multiples of 1. So then I've got 2, so it'd be like 2, 4, 6, 8, 10, 12, right? I guess I could put commas in these to make these a little spread out more so it doesn't look like 23 and things like that. If you want to put commas in, you can. And then we have the number 5, so right, it'd be 5, 10, 15, 20, and then my last denominator is 10, so we 10, 20, 30, right? We would need these multiples to find the least common denominator anyways, so we want to look for the least common multiple. So if I look at these, the smallest number that they all have in common is 10, okay? So we could times this by 5, times this by 2, and then times this by 10, and then worry about it. But I'm going to show you a trick with this least common multiple that allows you to not have to worry about the fractions at all. We're going to remove them, which I think will make you guys really happy. I'm going to do the same thing, though. I need that common denominator, common multiple, okay? That's why we still need to find it, and that's why we're talking about it. What I'm going to actually do is I'm going to multiply the whole thing, so 2 really big parentheses, and I'm going to do it by 10, but put it over 1 like a fraction, okay? So I'm still taking that least common multiple, or that least common denominator, and I'm still using it. I'm just not going to change everything to the common denominator. It's extra work. And then I have a bunch of fractions, which I know you guys don't like anyways. Okay? So here's what it looks like. And after a while, I'll show you kind of the shortcuts to do this too, okay? So what we do is we multiply everything by 10. So I'm going to multiply 7 by 10 and then 10 by 1, right? So it looks like this. I'm going to go 7 times 10 over 10 times 1, right? So I'm taking this fraction and timesing it by this fraction, and then I'm going to write n. So then the next one, I would do 3 times 10 over 2 times 1 equals 3 times 10 over 5 times 1 n plus 2 times 10 over 1 times 1. And I know right now you're like, the fractions aren't gone. How is this helping me? Don't worry, they will. So 7 times 10 is 70, and 10 times 1 is 10, n, plus, right, this is 30 over 2, 30 over 5, n, plus 20 over 1. Okay, so again, fractions are still there, but watch the magic. They're going to all disappear. What's 70 divided by 10? 70 divided by 10 is just 7. So this is 7n plus 30 divided by 2 is just 15. 30 divided by 5 is just 6n. And 20 divided by 1 is just 20. Look at, fractions are gone. I promised you the fractions would go away. And now we can solve it like we have in 7-1. So I would then move my 6n, right, because that's the smaller coefficient. I'm going to come over here. I get, well, that's 1n plus 15 equals 20, because this goes away. I can then just subtract 15, because that needs to get away from n, and I get n equals 5. And I'm done. And that's how you get rid of those fractions. All right, let's try the next one. So the biggest thing we need to remember, though, is to always make our whole numbers become fractions as well. So I'm going to put 6 over 1 and 4 over 1. And so my denominators are 7 and 1. And so if I listed the common multiples, right, if I listed the multiples of both of these, I would get that the least common multiple is 7. So I'm going to multiply this whole thing by 7 over 1. Now, I'm going to take out one step. I'm going to take out this step so that we can get straight to this step, okay? So I'm going to do this step in my head and then write it this way. So I'm going to go 7 times 1 is 7, and 1 times 7 is 7. I'm going to get k. Minus 7 times 6 is 42, and 1 times 1 is 1. Equal sign. 7 times 3 is 21. 1 times 7 is 7. Okay. Plus 7 times 4 is 28 over 1 times 1 is 1. So I did this whole step right here that I did up here, but I did it in my head, and I just did it one thing at a time. So now I can reduce all my fractions. So 7 over 7 is just 1, so I get 1k minus, well, 42 over 1 is just 42, equals 21k, or 21 divided by 7 is 3, and then I go k, plus 28 over 1 is just 28. And now it looks like a multi-step equation. So I'm going to subtract k first. Okay, again, I'm going to come over here so I have space. So I'm going to get negative 42. Do not lose this negative, this minus sign right here, okay? Equals 2k plus 28. Now it's a two-step, so I'm going to minus 28, minus 28. So that's 10, 4, 5, 6, 7, and we get negative, because they were both negative. If you put that in a calculator, put negative 42 minus 28, you're going to get negative 70. 2k, I'm going to divide by 2, and we get negative 35 equals k. And there's our answer. All righty. So what I'd like you to do is, first put this over a whole number. I want you to pause here, and I want you to go find the least common multiple of 2, 1, 6, and 4. I know I just said those totally in wrong order, but what would be the common denominator, common multiple that I would want to multiply by to get rid of these fractions? So pause, see if you can at least find the common multiple right now. So if you listed them, you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For 2's, 2, 4, 6, 8, 10, 12. 4 would be 4, 8, 12, and then 6 would be 6 and then 12. And the reason I stopped there is because we should have said that it was 12. So we're going to multiply this whole thing by 12 over 1. All right. I'll do the first step with you. So we're going to go 12 times 5 is 60. 1 times 6 is 6. And then I'm going to put the y back. 12 times 1 is 12. And 1 times 1 is 1. Equals 12 times 1. I'm going to put the negative there because I have to have a negative. See it right there? Is 12. And 1 times 2 is, I almost put 1, is 2. And then put your y back. Plus 12 times 1 is 12, and 1 times 4 is 4. Okay, so now I want you to pause and see if you can reduce all of these. So when you reduced here, you should have gotten, not 5, 10, y plus 12 equals negative 6y plus 3. I got negative because this was a negative 12 divided by 2. See how it was negative in the first place. All right, I'm going to add 6 to both sides. That's a smaller coefficient. I get 16y plus 12 equals 3 because this cancels. I'm going to subtract 12, and then I'm going to go over here. I'm going to get 16y equals negative 9. Put that in the calculator. I'm going to divide by 16, and I'm going to get y, it's a horrible y, equals negative 9 over 16. I'm going to leave it. It's okay to get fractions. It's okay to get decimals, and I don't care to go find the decimal for that because I don't need to. Okay, you can if you want to, but I'm not going to. All right, let's do this again. Let's pause. Don't forget to put these over 1. What would the least common multiple be for 2, 1, 3, and 6? Pause, go find it. List those multiples. So we should be timesing this by 6. 6 over 1 would be my least common multiple for 2, 1, 3, and 6. All right, I want you to pause and see if you can do the distributive property. It's really important you guys pause here. All right, when you distributed, you should have gotten 6 over 2x minus 30 over 1 plus 12 over 3x equals 42 over 6x plus 24 over 1. All right, I'm going to reduce. I get 3x minus 30 plus 4x equals 7x plus 24. So the first thing I'm going to do this time is see how I have a 3x here and a 4x here, and they're on both sides, the same side of my equal sign. I'm just going to put these together. This is a positive, and this is a positive. I'm just going to put them together. So 3x plus 4x would get me 7x minus 30 equals 7x plus 24. So I'm going to minus 7 from both sides. I don't really have room, unfortunately. Probably should have done it over here. I'm going to squeeze it in right here. So we're minusing 7x. We're minusing 7x. 7x minus 7x cancels. 7x minus 7x cancels. We get negative 30 equals 24. Now, some of you saw that in a scavenger hunt yesterday. This is what we call a no solution because nothing works. This isn't true ever. This doesn't work ever. Okay? Negative 30 will never equal 24. These are not equal, so we call it a no solution, which like some of you saw on the scavenger hunt. All right, so things to remember. We need to multiply. Well, we need to first find our common multiple. Find the common, so I'm going to put least common multiple. And then step 2, multiply the entire equation by the LCM. And then step 3, solve, well, reduce and solve like 7.1. All right, there you go. So here's your independent practice. You'll notice it's a lot smaller than the problems we've done. Okay, so I want you to see if you can do this. Everybody needs to try. Do your best. Rewatch the video if you need to. And I'll see you next time. Adios.